Welcome back to our series on techniques of integration. In this video, we are going to talk about integration technique of the product of the powers of sine and cosine in the form the integral of the jth power of cosine x and the kth power of sine x dx, where k and j are even numbers. And these are the four problems that we are going to solve in this video. The first item here is a prerequisite in order to answer problems number 2 to number 4. So let's begin answering our first problem. How do you find the antiderivative of cosine 2x dx? To answer this, let's recall our double angle identities. So from our basic trigonometry class, we have the following identities. The cosine of 2x is equal to 2 times cosine squared x minus 1. For the derivation, you can consult our other video for this. And from the first formula, we can derive the second and the third formula. In this video, we are going to use the second form more frequently in answering our problems. We need to recall also cosine 2x is equal to 1 minus 2 sine squared x. And from here, we can solve for sine squared x, which is equal to this second formula, which we can also manipulate to arrive at this third formula. We call these formulas as power reduction formula because notice that the right side of the second formula and the right side of the third formula do not contain powers anymore, even if the given sine function contains exponent. So these formulas would be very helpful in simplifying our integrand. So let's answer now this problem. What is the antiderivative of cosine 2x dx? To answer this, let's begin with what we already know. We are going to use the u substitution. We let u be this angle 2x, and therefore du over dx is equal to 2 or du is equal to 2 dx. But since what we have here is dx, we want to solve this for dx, so dx is equal to du over 2. And substituting now these values to our integrand, we now arrive at the antiderivative of cosine. Instead of 2x, we have u. Instead of dx, we have this value du over 2. Then factoring out the constant 1/2, we have 1/2 times. We know how to find the antiderivative of cosine x dx. So we can also apply that formula to find the antiderivative of cosine u du. The antiderivative of this is sine of the angle plus c. And then, on substituting now again the value of u, we arrive at this final answer for the integral of cosine 2x dx. The answer is 1/2, which is this 1/2. Then we copy the sine function, replace u by 2x, because that's our substitution, plus certain constant. We need to remember this formula because we will be using this in our remaining 3 problems. Let's go to our next problem. So for number 2, what is the antiderivative of sine squared x dx? Notice that this form now is the same in form as this, where our k is 2 and our j, which is the exponent of cosine, is implied to be 0, and any number raised to 0 is 1. So you can think of this expression as 1 times sine squared x dx in order to fit this form. So clearly, both the k and the implied j value are both even. So how do you find the antiderivative of this function? We are going to use the double angle identities that we recalled a while ago. Notice here in number 2 that you have the form sine squared x, which is also this form sine squared x. And we are going also to use the formula that we just derived in problem number 1 as we go along answering this problem. So first, we do the necessary substitution. Instead of sine squared x, we now use this form. You have the 1/2. We can also write this as 1/2 times cosine 2x, which is this one, dx. From here, we know the antiderivative of 1/2, and for the antiderivative of cosine 2x, we already have that formula here. So let's apply the formula. So the antiderivative of 1/2 is 1/2 x. We copy this constant 1/2, copy the minus sign, and then the antiderivative of cosine 2x, the antiderivative of cosine 2x is 1/2, which is now this 1/2, times sine 2x, which is now this sine 2x, plus a certain constant. So what we did was we performed substitution by recalling our double angle identity, and we apply the value that we arrive at in problem number 1 to arrive at this last line. Then all we have to do now is to algebraically simplify this last line. So we now have 1/2 x, 1/2 times 1/2 is 1/4, copy all the rest, and that gives us our answer for our problem number 2. So the antiderivative of sine squared x dx is equal to 1/2 x minus 1/4 sine 2x plus c. Let's go to our problem number 3. What we have now here is sine to the 4th x dx. Still, our k value is even because 4 is an even number, and the j value is implied to be 0. So how do we find the antiderivative of this function? First, since we know how to find the antiderivative of sine squared x dx, then we can rewrite this as sine squared x all raised to the 2nd power dx. Here we apply the power of power law of exponent. From the double angle identity that we presented at the beginning, we have an expression there for sine squared x. We know that sine squared x is equal to 1/2 times cosine 2x over 2. We can now substitute this value again to sine squared x to arrive at this next line. So we copy the integration symbol. Sine squared x is replaced by 1/2 minus 1/2 cosine 2x, which is just the same as this form, only that 1/2 is written as a factor instead of dividing by 2. And then we copy this exponent 2, and we copy dx. Now, from here, notice that this is a binomial that is raised to exponent 2. So we can now square this binomial to arrive at the square of the first term, 1/2 times 1/2 is 1/4, minus twice the product of the first and the second factors. 2 times 1/2 is 1, and 1 times negative 1/2 cosine 2x is negative 1/2 cosine 2x. And the square of the last term is 1/2 times 1/2 is 1/4 cosine squared 2x. So this is just squaring a binomial. Then from here, we have this form cosine squared of an angle. And we have this form also here, cosine squared of an angle. The only difference is instead of x, we have here 2x. But it doesn't matter. We still think of this as just an angle. So we can apply this formula in order to simplify this third term. So copy all the rest and replace cosine squared 2x by 1/2, which is this 1/2, plus cosine, and then double this angle. Whatever is the angle, we double that. We have here x, we double that to 2x. So if the angle here is 2x, double that to get 4x. And then just copy all the rest. Now let's simplify this. We can distribute this monomial factor to the binomial factor. Copy all the rest. 1/4 times 1/2 is 1/8, and 1/4 times cosine 4x over 2 is equal to 1/8 cosine 4x, and copy all the rest. And then we have here a constant 1/8 and a constant 1/4. 1/4 plus 1/8 is 3/8, which is now this one, and we just copy all the rest. Now, we are almost done, only that we still have here cosine 2x. So in effect, that's the integral of 1/2 cosine 2x and another integral 1/8 cosine 4x. So we need again the result that we arrive at in problem number 1. Remember that the integral of cosine 2x dx is equal to 1/2 of sine 2x plus c. So we have this form similar in this form. So we know the antiderivative must be like this. And we can also extend this to this form, only that instead of double angle, we have here 4x, But the angle is just the angle. So if we use 4x for the angle here, we need to use also 4x for the angle here. So here is now our result. The antiderivative of the constant 3 over 8 is 3 over 8x. Then copy the constant. The antiderivative of cosine 2x is 1/2, which is this 1/2, times sine 2x, which is the sine 2x. Copy the plus sign. Copy the constant 1 over 8. Then the antiderivative of cosine 4x. Cosine 4x, our angle now is, instead of 2x, we have 4x. That is now equal to 1 over 4 times sine, and the angle is 4x plus c. Notice that if you have here 4x, the fraction in front of the sign is 1 over this constant, which is 4. Now from here, all we have to do is simplify. So multiplying now 1/2 times 1/2, we get this 1/4. Multiplying 1/8 times 1/4, we get this 1 over 32. All the rest are just copied. For our final answer, the antiderivative of sine to the 4th x dx is equal to 3 over 8x minus 1/4 sine 2x plus 1 over 32 sine 4x plus c. Now let's go to our last problem. What is the antiderivative of sine squared x cosine squared x dx? Again, let's recall the formula that we presented at the beginning about the double angle. Now, this sine squared x is equal to this expression, and this cosine squared x is equal to this expression. Notice that one is plus, the other is minus. So using now this value of sine squared x, we have 1/2 minus cosine 2x over 2. And using now this value, for the value of cosine squared x, we have this value 1/2 plus cosine 2x over 2 dx. We can factor out the 1/2 here and factor out also the 1/2 in the second factor. So we arrive at this form, and it is apparent that we have here the difference and the sum of two numbers, which is a special product. And 1/2 times 1/2 is equal to 1/4 that we can pull out of the integration symbol. So let's simplify that in the next page. Using commutative property, I write the plus first and the minus second, but it doesn't matter. Then 1/2 times 1/2 is 1/4, and we now have here the sum and difference of two numbers, which is a special product that results to the difference of two squares. So we get the square of the first minus the square of the second. So this is the product of this sum and difference of two numbers. Then again, you have here cosine squared 2x. And you have here cosine squared x. The only difference is you have here 2x and you have here x. And when you have x here, the angle in the answer is twice that. So if you have 2x as the angle, the answer when you substitute that in this formula becomes twice 2x, which is 4x. So using now this form, we arrive at this. We copy the 1/4, we copy the integration symbol, we copy the constant, and then this 1/2 is this. Since you have here 1/2 and 1/2, we just factor out the 1/2. And what is left inside the parenthesis is 1 plus cosine 2x. So you have 1 plus cosine times twice whatever is the angle here. So you have 4x, and then copy the dx. Then we can distribute this monomial factor to the binomial terms. So 1/2 times 1 is 1/2. And then this negative 1/2 times cosine 4x is this minus 1/2 cosine 4x. Everything else are just copied. Then we can now add 1/2 minus 1/2 is equal to 1/2. And then just copy this part. And since this is now a form that we know how to find the antiderivative, we now perform the integration. From our problem number 1, we know that the integral of cosine 2x dx is equal to this formula. We can apply that to simplify this part. Instead of 2x, we have here 4x, but still, it's just a matter of adjusting the angle. So to find out the antiderivative of this, we copy the constant 1/4, The antiderivative of the constant 1/2 is 1/2 x. And then we copy again the 1/2. The antiderivative of cosine 4x is computed using this form. Then copy sine 4x plus a certain constant. And then we can multiply 1/2 times 1/4 to get 1/8. And you have here a monomial factor that you can distribute inside the parentheses to arrive at 1/8x minus 1/4 times 1/8 is 1/32. Then we just copy all the rest. So for our final answer, the antiderivative of sine squared x cosine squared x dx is 1/8x minus 1/32 sine 4x plus c. So these are some of the techniques of integration that we used in order to find the antiderivatives of certain product of the powers of sine and cosine functions. Thank you very much, and we hope to see you again in our next video.